Testing, test. Okay. Okay. All right, looks like my live stream is doing everything it should. I believe. Let me just double check. Having a little trouble telling if my stream is healthy. And it looks like it is not. I need to listen to this. Okay. So that's confirmed. Well, I think we're up and running, but I'm not sure if I have audio. So I'm going to stop this stream and restart it. Just give me a chance to check and make sure it's working as intended. Testing, testing. I'm checking for audio. And it's working fine. Okay, I think we can get started. So, welcome back everyone, or anyone. So in the last video, I finished up some of the foundation work for my request history database table and a set of routines that'll read and write to from it. The next thing I have to do is plug it in to my core application, which has 4 or 5 processing steps in it. And each time it hits one of those steps, I want to record some additional history information for this request in the database. Now the reason I'm doing this is when you do some work with Lambda and you're using CloudWatch to as your logging system, you'll quickly find that the threading model of Lambda necessarily enforces some weird behavior in the logs. For example, when someone calls your Lambda function, presumably, when someone calls your Lambda function, or you call it, if the function hasn't been run recently, Lambda will have discarded any running context information from it. So it takes a minute to power up a runtime, or not a minute, but a few seconds to power up a runtime environment, get it initialized, and get your code loaded into a Node.js instance running inside that. Once that's up and running, it stays running as long as it continues to get traffic. If it gets cold for too long, AWS will shut it down, and then you go through that whole cold restart procedure again. If you get 10 requests at once, it'll fire up 10 instances of the Lambda function, separate instances that are completely unaware of each other. So when you look at your log files, they're organized by the Lambda function, which is good. So all my logs for my function XYZ are grouped into one subdirectory, so to speak. But then it's split into multiple streams, as they call it, and I'm guessing, but I think each stream is related to a running instance of your Lambda function. So any given instance of a Lambda function, running instance, might handle requests from all sorts of different customers or requests of different context, essentially. So rather than getting a nice continuous log that shows me each step along the way for a given customer request, instead I have to hop from log to log to log to piece it together. And that will make debugging with my commercial clients virtually impossible. So far better that I put in a better, more specific logging system that will serve not only my debugging needs, but customer inquiries, so they can inquire themselves and see what the history of a particular request was. I might not expose all the data to them, but I would certainly expose whatever they need to debug things on their end of the integration. So that's the task. The next task is to glue the usage of this library and database table into the other 3 or 4 processing steps that I haven't put it into already. And then I can move on completely from request history and bite off whatever's next. So let's get started. The first thing I think I'm going to do is run a complete system test in development, just to make sure that when I went for my nap last night, that I left things in working order. So let's run our system tests. Now this should also include the new request history tests I added in my last session. And I see one problem here. Request history query number 1 is wrong. So that was here. No. I believe it should say that. You notice it runs a lot faster than this because all my so-called container startups didn't need to happen. They're already hot. Okay, so yes, query number 1, query number 2, much better. I'm not sure I've checked this in recently, so maybe I should do that next. I'm using Git and GitHub for this project. So I have local clone repositories on my machine here, and I have a GitHub account that I think costs me $7 a month. And I set up a repo there, and that's the primary, my master repo, so to speak. So I can pull this project down onto any machine, build it, and deploy it um, without regard for worrying about the machine my source code is on, because my source code is not only on this machine, but it's also in the cloud in GitHub's database, and any other machine I might clone the repository into. So looks like I have a few files to commit here. Not node. I'm going to add all those. Those are all new files or updated files. Looks good. And here I request history. It was test plan. Test plan dash request history is working. And I'm going to push those changes to GitHub, so there's another copy. Good. Now, related to that is the desktop I'm using here. And the desktop is a Windows instance that's running in, again, Amazon's cloud. In this case, it is an EC2 instance. I know I said that I wasn't using EC2 instances for this project. Well, I lied, I am. I'm using one for a desktop. But the runtime, of course, is entirely non-EC2. It's entirely Lambda, DynamoDB, SNX. Now, the reason I'm using an EC2 instance is I initially decided to use Amazon's Workspaces, I believe it's called. And for 25 bucks a month, you can get yourself a remote desktop in their cloud. They'll patch it, they'll update it, they'll back it up. Essentially, it's a VM running somewhere in their hardware infrastructure. So, in order to test my application, one of the things my development workstation needs to do is open a TCP/IP port and accept an inbound connection from the internet. So that's a little tough to do in a properly protected desktop. Bare minimum, you're going to have to open a hole in the Windows firewall. But if it's an Amazon Workspaces desktop environment, well, they've got their own layer of network protection around it that it probably would have taken some time to drill through, even if I was successful. And at the same time, I realized, or after a month or two of paying $25, I realized that the free tier of AWS that I'm developing all this code on and for, it includes one free EC2 instance, as long as it's one of the really, really tiny ones. 1 or 2 gigabytes of RAM, something like that, 10 gigabytes of storage. Excuse me. So now, from an EC2 instance, I can open a port. It's easy enough to open a hole in the Windows firewall, and that's all I had to do is open the Windows firewall, a small port range, and then I could accept an inbound connection from a remote process on the internet. So that got around kind of 2 problems. It saved me 25 bucks a month, and it allowed me to accept inbound connections. So that's what I'm using as my desktop. But as I just mentioned, my desktop could really be anywhere. Because, sorry, I lost my train of thought. My desktop could be anywhere because I can pull this GitHub library down, clone the repo onto any desktop I need. And I've chosen Windows for my desktop on this one. And I would be, well, almost up and running. I'd still need to install all my tools. And I'll just briefly tell you what they are. I think I covered some of them. I'm using the Sublime Text editor. It's always handy to have Notepad++ kicking around. Downloaded and installed Node and NPM. It comes as a single install package, actually. And that's probably about it. The rest of the tools I use are largely available on the web for free, such as a JSON editor and I don't know, a ping and a whois and various things like that. Of course, I had to install the Git client on this Windows instance as well. I think that's about it for tools. Anyway, let's get into the coding part of it. And first, I'm going to need to see where we are. In terms of which components are already using the logging service. I'll just bring this over here for you. So in my request history, I have lots of data. I don't know which of this data was created recently and which was old buggy code, so I'm going to delete all those rows. And then I'll rerun my system test, which will create new rows. Finish, refresh, and there we have it. Two different tests caused us to write a row here. This is strange. How do I open up this record? Doesn't seem right at all. I'm going to refresh the page. Something's funky. There we go. Now they're hyperlinked. So here's where the steps get recorded. So my lock request is doing it, and my lock grant is doing it. So all right, so I know that I have a few other ones I need to do then. I do want to do this one. But that one's a little trickier. I'm going to have to think about that one. Let's go over to our microservices. So this application has been factored into microservices. In fact, one might even call them nanoservices. Its public API is already a microservice, but then the functionality behind that API is broken up into smaller pieces, which are each callable not as subroutines, but through SNS, or actual HTTP calls, which turns them essentially into microservices that are even smaller than the microservices of the outer container, hence the term nanoservices. In fact, I'm on an email thread on the Amazon discussion forums where we're chatting about that, trying to figure out what the right size of a microservice is. But so far, all we've come up with is everyone seems to have an opinion. But no one has really a working implementation. See, at the end of the day here, I can deploy and manage each of my nanoservices, the inner ones, as well as the outer ones, individually. They're each a separate code base, separately deployable, which is one of the primary architectural attributes of a microservice-based approach. Matter of fact, I should add microservices to the keywords for this video. So anyway, I'm going to do arbitrate first. He gets a lot of traffic, so we'll see some real chatter recorded from him. And then I think we'll go build a utility that just grabs and prints out the activity for a particular request. A command line utility would be handy. Okay, so let's go update Mr. Arbitrate. First, I'm going to get rid of some of this stuff that I don't need. We're done with that. Get rid of our testing stuff. Keep that. Oh, I should have kept one of those. I sure wish we had a recent files. Open recent, look at that. I'm going to keep block open because I'll be stealing code from him to put into, I haven't opened it yet, my arbitrator. So he's in, so this directory is called M service for microservices. I probably should have called it N service for nano service. Let's grab, we'll need the build file too, since we're going to add the request history module to the dependency list for arbitrate. So I'll just add it here. History DB. So I'll move this one. No. Wrong one. There we go. Lots of windows. Very handy. Get down to the arbitrate directory. Install the dependencies, which will now include my request history, which in turn includes the UUID library I'm using. Okay, so that's good. Arbitrate, top of the pile. Looks like I didn't update the documentation. I'll have to update that a bit later. One of the things I don't want to do is give out too much information about the app I'm building. I haven't decided whether it's going to be a open source thing or whether it's going to be commercial. So I'm not going to give away too much info in that area. At least not yet. I like a space after my requires. And we'll need request history DB as well. So arbitrate, actually it's not locked that I'm going to copy. I'm going to copy from, now that I think about it, no it isn't in microservices, user callback. Change that to, yes, history. Good, and then turn that off. All right, so if I should do this at the end of each process rather than the beginning. It'd almost be nice to do it at both ends for maximum traceability, but I don't want things to get too chatty and noisy. I think we'll start with the beginning and just, it won't take much to move it to the end if I need to. So I'm going to just, there it is. It's really the only block of code I need. The thing is, I'm going to have to insert it here. As long as I have my global and local variables set up, I'm okay. I don't like heavily nested JavaScript with inline callback functions. I use them to 1 or 2 levels when needed, but in general, I try and pop out to a new function to keep the code readable. It does make for weird code, but that's life in the asynchronous world. Okay, so it looks like I have to go in here. Yes. This will have to be function step 0. Which will be taking, well, we'll see. We'll fill that in later. Now my code goes here. Yeah. And that's exactly it. And this goes here, and that needs to be indented. Well, there's really no point in doing that, is there? Might as well launch this call right in there. Yeah. Okay. Bit of room. All right, where did I put that? Okay. Now I must change my error messages. So to 25. And this error would be, yeah, exactly that. But I should really add the process name, and I should really do it in user callback too. And it's not a block grant, this one would be arbitrary. I'm not sure it's, yeah, it is exit there. Uh-oh, this looks bad. Calling it with 3 parameters here and 2 parameters there, so which is it? I would imagine it's 3, except with error. No, it's only 2. That's weird. That doesn't look right at all. That looks like old code to me. So let's have a look at you. That's more like a 3, not 2. And no stringification because Lambda Lambda will stringify this object for you. when it returns it. So there's no need to stringify it yourself. Okay, so we'll put the new shinier function in, and then go find out where we used it and fix all the calls to it. So this one is right, 3 parameters. This one is not. And that's it. Only used a couple of times. Good. But it does beg the question. Yes, this had the nice one. Let's make sure all these calls are right. Oh, there's only one call. All right. Anyway, back to arbitrate. We might have been done. I think we are. Didn't take much. Right here. All right. Let's run the test harness for it. I want the local one. And of course, our event. The test harness constructs an artificial Lambda event and calls the code, and it runs locally here on the desktop. But when I construct that event, I have not included the newest requirements. Oh, it's not even what this error is. It's more like this. Okay, let's address the problems that are in front of us. Yeah, there we go. That's the error I was expecting. Request history is not in the event. Therefore, it can't address it. So we'll need to open the test. Good heavens. Fix up this. No, that's not right. That's what I want. And I will come back and fix that up. Okay. Now this is a case of wrapping one thing in another in another. So in this case, I need to insert a request history object in our stage variables, I believe is what we're doing. Yes, it is stage variables. I'm just going to grab that so I can look at it over here. So, that would mean I do have env and current request history equals new request history. And I think it took like 7 parameters. Now, since this is all test data, I don't really need, since this is a test harness, I don't need real data. for this parameter because it is a hard-coded list that I have to match. Okay, so that will put it in our stage variables, which will get swooped up by that. Wrapped in that, and passed into the Lambda handler as an object. So that should do it. Let's try that again. Yeah, this is not correct. I need M pointing to the library, not the result of load environment. So this should be just a load environment. So we loaded our environment, step 1. Okay. I wonder if that worked. I see a new row on my table, and sure enough, this row here, and sure enough, we now have an arbitrate. Now, do I have I'm wondering if I should have oh yeah, here's all the parameters, okay. Not sure I have the lock hash here. Oh, this is the request ID. Yes, the lock request ID. Good. Okay. That should be fine. So if I look in our, well, I'm not going to bother. Okay. That seems exactly correct. Now I need to deploy this code to Amazon using my deploy script. And then I should be able to run my testing infrastructure. Let me first clean up that database table, get rid of all the records on it. And I should be able to run my system test and see that my arbitrate module is adding information to the request history for that request. All right. So I see 2 here. Step type lock request, correct. Arbitrate. Lock grant. Looks right to me. Okay. Well, things don't normally go that easily. Let's see if we can maintain our good luck and get it done for the other modules. I guess I'll get rid of my model now. I'll use these guys as the model. So next one up, update lock is a fun one. Let's see, test update lock. I guess we have two of them. A few files for this one. Alrighty. Yeah, don't do that anymore. Now, what are you doing way up there? Supposed to be down here. Let's start here. So same deal. He's going to need the RequestHistory DB library. And, oops. Oh, come on. Ah! There we go. That looks right. Get rid of that window. Update lock. Alright, so a lot easier if you were at the bottom, along with your buddy. So in arbitrate, I added this. I need some of the same. And I added this block. We'll have to do the same thing to update lock. We start step 2, that's nice. So this will be message is defined. Good, that'll work. This step is update lock. I'm going to call it by its correct name. Now instead of this, we will be doing this. That's about it. Now, is exit with error sane here? Should take 3 parameters and not be stringifying the outbound object. It's all looking right. Well, this is interesting. Well, that sure as heck won't work. Exit with error will not do a %s. So there was something in util. Well, I could just use plus signs. low-tech and hacky, but it'll do the job. No, comma, space, and then the other thing. Something's not right there. I've got a quotation problem, or Sublime Text is confused, and I think Sublime Text is confused. I've seen it get confused on curly braces before, telling me there's a mismatch when there isn't one, and occasionally with the quotes too. So there's the match for that. Doesn't do matching quotes. Huh. And here's a new, oh, this is not right. Comma space, yeah. Plus lock hash, plus that. There we go. So it was right, I was wrong. Got it. No, that was a badly bungled call. Okay. Oh, this is interesting. Well, I don't know. I'm not going to put that level in yet. Anyway, exit with error, right? 3 parameters. 3 with error, that is the new one. Well, the other one had 4 lines of code in it, I thought. Yeah, that's not right. That should have a status code on it. Okay, let's look at Mr. Arbitrate. It's like one of my global search and replaces. Yeah. Screwed things up. Didn't see that one coming. I better do a global search and replace on that. Lock request ID. 1 replacement. Okay. Now what is this doing? Oh, right. That's creating one of my own result objects. Yeah, this is the version of the function we should be using. Well, I should have put it in a library. So 6, 8, 2, 2, 12, 46. That number is just a unique ID. One of the things with, well, any application development really, is when an error message is issued by the application, you need to know where it came from, what line of code. And often that's given to you in the stack trace or the exception handler. Other times it's not. Messages don't always get reported that way. So I've adopted a strategy for programming in pretty much any language, doesn't matter, that when I output a message, I put a unique identifier on it. And that way I can search the entire source code repository for that unique identifier. And boom, I'll know exactly which line of code that error message occurred on. I don't think I need two of those. Now, how to come up with those, I'll probably tell you in a future video. I've got a cute little system. So yeah, I guess that's all I need there. Now, testing this is going to be a little tougher. It's dependent on data existing in the database. So I might have to set that up. Yeah. But it only takes 2 seconds, so it's no big deal. So what did I do here? I added this. I'm going to work on the test harnesses now. Sloppy. Good, that's already there. Right, so once again, we're simulating, this test harness is creating a fake Lambda event, which just like the other time is something wrapped in something wrapped in something. And seems rather strange. I haven't used this code in a while, it wouldn't work. Test event isn't defined. It looks like it should be this. Wrapper. Should really call it event. Okay, so I think it's this lock request ID that has to exist in the database already. Otherwise, so we do have a lock on the database, or a lock record in the database. I'll just grab the ID and plunk it in. Oh, geez, there's 2 different IDs. That's the queue. I see the queue's getting. Let me just think on this for a sec. Yeah, so this is going to be the lock identifier. And this queue, I don't think. Queue, which is defined here. Yeah, that should all be fine. Just had to create a fake queue. Okay. That will probably work. Header, isn't it? Let's put a nice one in. And we are 22 August 2016. This is called test rand lock 0. Local.js. Get rid of that. And let's give this a shot. Okay. Update log line 247. Oh yes, extra pair of braces here. Like I did not insert. That's right. There was one more line I had to add. this one. That will hide something that gets wrapped in something that gets wrapped in something else. And it makes things work. Okay, that is success in my book. So let's deploy it to Amazon Lambda and test it. We'll do a same thing. We'll run a full system test. I'll clear out the request history table. And we can have a look. And let's do it again. I don't have a cough button for my mic, so I'll just use the switch. And I see 2 rows over here. This one looks busy. So, lock request, yes. Arbitrate, yes. Update lock, yes. That was the one we just added. Arbitrate, yes. Update, perhaps. If I see a grant, yeah, there's a grant. Good. Nice. So now I have a nice history. I just need to do one more, I think. One more process. Okay. And that would be I don't need these 2 anymore. I can pull these to the bottom. Update lock is done. Who else do I need? User callback I've already done. Although I did want to change it. He's recording lock grant. He should record user callback. User callback. Okay, that looks good. Something else I think I overlooked. Well, no. Oh, I haven't finished with these guys yet. There's the remove lock. Oops. Okay. So grant lock, I'll just copy some of this code over. This line in the middle. Here's my remove message. I'll need a lock ID again. One that exists. So there's one that exists. And again, this code is screwed up. It's called event. I haven't run this code in months. And it accumulated some bit rot as I changed things here and there. This is the wrong name. lock. I don't think I need lock. And what did my header look like over here? Let's steal the header too. May 15th, huh? Okay. Now what? Yes, that's all true. I think that's it. Let's try that. This will be a remove. And it worked. Very good. Okay. I think we already did deploy, didn't we? Well, we'll deploy it again, just in case. The test harnesses don't get deployed to Lambda. They only run locally on my workstation. Okay, what's up next? Probably another system test. How long is this video? I want to cut it at about an hour. Do a break maybe and then come back. What time is it? It's 1 p.m. 1 hour, 3 minutes. And no one's watching live, so I don't think there'll be, I don't think I'll be disturbing anyone. But these are going to my channel, so they can be viewed later, and hopefully that's why you're listening to this. So let's run one more system test and just make sure that, no, we have to integrate it into one more, don't we? And that was user callback. I just fixed that. Update lock. We just did. So I guess it's just delete lock I need now. Let's do that. Let's do delete lock. So we're going to need those. Oh, geez, we don't need that file anymore. They didn't land where I wanted. Okay. Add the library. Update lock. I want to be in delete lock. Stop it. So I'll just finish off getting this integrated into all the modules that need it. I think this might be the last one, and then I'll break the video there. Okay, so same procedure as before. Okay, did I get rid of update lock? I did, didn't I? Darn, I need it as a template. Keep my template at the top for grins. Okay, I did that, right? And I did the build, we got that, so good. So delete lock is going to need step. Okay. Looks like it's going to be just like the other ones. And this is going to be delete lock. Another unique message ID. Actually, as I close off this video, I'll tell you how I create those unique IDs. Then, instead of that, it's going to be this. And we call step 1. Oh, of course. It's right there. Good. That's a rather unneeded comment. Okay. And let's just have a look at exit with error. What the heck? Bug check. No, exit with error. That seems strange. It was 4 lines in the other one. Oh, it's logging something to the console. But this won't be coming from an outside API request, so I don't think I care. Do I really use bug check anywhere? I didn't think so. That is dead old code. And why is your brace in the wrong position? That's better. An extra line. And let's give you a modern header. I didn't come up with my header standards until I was halfway through this. So now I get to retroactively apply them to a few things. 22 August. 22 to August. August 6. Good. All right. That looks better. But hey, that's what coding is like, right? You go back and sweep up and sweep up, and there's never a day where you open the code and don't see at least one thing you want to change, whether it's a comment or an error message or the way I designed that loop. Okay, let's test this, make sure delete lock is recording request history as we intend. But yeah, this process gets invoked completely out of band from any user call to the API. So the notion of a request ID went by in time quite some time ago. So really what I should be doing, I should be looking up the old lock request history record and appending to it. But the code, the way I've got it here, it's just going to create a new lock history record for this action, which is not really what I want, but it'll do for now because I don't much care about delete lock activity. It happens, as I said, out of band after the fact, and really it's just a garbage collection activity. It's not related to the functionality of the application particularly, unless and until the garbage keeping interferes with the primary requests in the application. But if I've done things right, that won't be the case. So I think in the interest of not developing a feature that I don't currently need and can be easily added later, I'm going to leave this the way it is. Which means I can test it. Oh, right, so I have to, did I fix this yet? No, definitely not. So, delete this. Sloppy. Again, crappy old header. Actually, this is not called that. Local. Harness for block. Oops, wrong year. I like to put my name on it in case any copyright stuff ever comes up. It's never happened before. That'll do. Oops, should have been June 16th. I do like to know the original dates that I wrote things. Helps me keep the timeline in order in my head. Okay, so now we need to build a fake test object, or no, get our stage variables set correctly. Okay. Delete lock, so we're going to need a real lock ID here again, which I can probably just take from here. Once I delete it, it'll be gone. Okay. That'll do. All right. This was some debugging that I was doing. I don't need that. And let's just call you event, the way I did in the other ones. All right. Now what? Will it run in the test harness? It ran in the test harness. Did it delete a lock? We can tell by rerunning it, it should fail. Request queue no longer empty. Oh, okay. That is true. I need an empty request queue. Just using my web browser to make it empty. Try it now, smarty pants. And it looks like it did it. I can just show you here. See, there's our lock request, or sorry, that's our lock. If I refresh, it's gone. So we did delete it, which is exactly what we were hoping for. So that seems to work. I'll deploy. It is now in Lambda. Usually I have to wait a few seconds after a Lambda deployment before the module becomes active. If there are any requests in flight with that particular module already, they're going to need to die down, and then Lambda will power up your new one for you. But of course, every time you deploy, you incur the cold start expense on the first user call. But as long as you keep it busy after that, you won't get a cold start again until either traffic dies down or you deploy new code. Or at least that's what all the videos and talks I've read say. Okay, so time to run a system test, I think. And then we can see if we get all the activity recorded in the request history the way I need it recorded. Now this system test stuff is not running any of the application code locally. It's actually hitting my API gateway APIs and calling my publicly exposed functions, getting answers back, and ensuring that those answers are the correct ones. It also does some direct calls to DynamoDB, read and write to tables and indexes, make sure they're all present. But unlike the test harnesses that we've been running for the past hour, this system test is testing the deployed application in Lambda, not running the code locally. And so we got no errors, very good sign. I can see that we got a new lock record, which is right. And I forgot to clean out this table, so now I'm not sure which is which. So yes, delete them all, and then rerun my system test, please. Well, that's a longer pause than I was expecting. Okay. And we got 2. See, if delete lock was recording things the way it should, we'd only end up with 1 event for the history of that lock. So let's have a look. So this is be the big one. Lock request, check. Arbitrate, check. Update lock, check. Arbitrate, check. Another update lock, yes. Lock grant, yes. Now we should see a delete lock here. Oh, it says lock grant. That is not right. Not right at all. It looks like my delete lock is putting the wrong message out. It sure is. Should be delete lock. I wonder if I change this, I better make sure. Okay, let's do all that one more time and make sure we've got it straight, since it only takes a second. So first I'll clean up the request history table. I'll even clean up the lock master for grins. And then I will run my system test. Boom, and I better not see a big pregnant pause on this one. That's still slow. Okay, I'll look into that later. So, not lock master, request history. So again, my 2. So step type, lock request, arbitrate, update lock. I missed an arbitrate. Oh no. No, that's right. Lock grant. I did miss an arbitrate somewhere. Arbitrate. Huh. Well, maybe not. Okay, let's see what our delete lock looks like. Ah! It's not a lock grant. What the hell? I changed the code. I didn't deploy it. Ah, dear. I did deploy it. I ran the test too soon. As I mentioned, deploying new code, sometimes you gotta wait for a moment. So I'm just gonna delete from those 2 tables again. What did I do with I've lost, yes, I lost my window. Oops. Here. Request history, yes. That can be a little confusing when you deploy a change, run your tests, and it looks like your changes didn't deploy. You're still running the old code. I've learned that take a breath, pour a cup of tea maybe, come back, and then your code will have changed. Now this should have been plenty of time. I wouldn't expect to wait longer than this. And if this doesn't work, then I will assume that I did something wrong. I did something wrong. It still says lock grant. And it certainly should not. What did I do wrong? Then delete lock. Oh, that's in the error message. Well, that's okay. Here's the step. What's wrong with that? What code did I deploy? Delete lock. Okay, that's strange. Well, I will publish it again in case something went wrong somewhere upstream from me. I'll clean out those records and run the test again. Still taking too long. And let's see if our delete lock, oops, wrong one. Still says lock grant. Very strange. That message no longer exists in this program, so how is it getting into the database? You know, that tells me I should put unique message IDs on all these things. Two. 20. I'm going to go back to all of them and put a unique message identifier, because now I'm not sure where that lock grant text is coming from. Well, there's an ID. I could show you my search mechanism. So in order to search the entire body of the code of the application, I've had to do a couple of things. First, the problem with searching all the JS files is that if you, well, we've used NPM, I've used NPM to import modules that my modules depend on, and they end up getting searched too. So really I just want to search just my code, not any of the dependent module code. So just a very simple hack to take care of that is to check everything into Git kind of as a temporary check-in. Lots of changes. Git add everything, git commit, and I'll just call this an interim check-in. And I have to push it to GitHub so I can subsequently pull it. So in a completely separate directory tree, I have another copy of the project. And all I do is pull this code down into here. But since I never develop or run or execute or anything in this separate directory tree, none of the dependent libraries need to be installed. So this directory tree now is just my code only. So I can find a string. I'll show you the whole command. This is DOS, so it's find string. And the string I'm looking for, which in this case will be a lock grant. Next case, oops, you also have to say spin. Case insensitive, search subdirectories, asterisk.js, and look at that, all sorts of instances. Well, this is not good. I see lock grant showing up in arbitrate, update, lock, and user callback. I expect it in, well, maybe I do expect it there. Maybe not in user callback though. Reset lock is not running anywhere on Lambda. Neither is lock client. So I don't need to worry about that. It's really just these three microservices. Okay. It doesn't occur in delete lock, which is consistent with what I saw. So, update lock, lock grant. Let's do case sensitive. That's not right. This should be update lock. And that's it. No more lock grants. I saw it in arbitrate too, didn't I? Oh, I was going to put message IDs on this, status codes. Not really status codes, they're more message IDs. Oh, but that name was taken, so I ended up having to use status code. Arbitrate. So, 62.2.13, 21 ought to do. Oh, crap. Well, that's probably okay. I was intending to select and sort on this string when I retrieve these rows from the database, but I could select and sort on the entire string. That's okay. So that was arbitrate, update lock. 62.2.13.22. That's fine. Arbitrate, delete lock. Something happened. Oh. Looks like my session with AWS timed out on the web browser. You have to log in again every probably 24 hours or so. Okay, so we did that. Arbitrate. What am I missing? Service. User callback. No, I haven't. So, uh-oh, there it is. Phew, thought I lost the code. Yeah, we need one here too. And it's not lock grant, it's user callback. 6822.13.24. Well, I think I might invoke my build all script since I've now tweaked all the code that's running on Lambda. So why don't we do that? I haven't run it in a while, so it might blow up, but we'll see. Everything's saved. I feel like I've left something and I can't. Not sure what it is. Okay. I got those. Oh, okay, that's fine. Oh, I should change that though. Test plan request history. How do message is there? Nah. No, that's not true. That's test data, I don't care. Alright, well, let's clean up some of this. Alright, can I get a system test? Right, so I'm going to wipe the table clean. Oh, you're kidding me. Just going to refresh all my AWS sessions here now that I've relogged in. Okay, request history, items. Pull that over here. There's a couple of rows we'll get rid of. Now I better not see lock grant in that other message. Do it. Oh crap, I haven't deployed the code yet. Stop doing it. Okay, so to deploy all the code in one shot, I have a big old batch file, deploy all AWS. And what it does is walks into every directory that needs it and builds the dependent libraries and then deploys to AWS. Let me just type that out. Right, so it's deployed in 2 steps, my microservices or nano services, and then the API. So I think let's do it. This is the stuff that if you don't build it, your automated deployment and testing stuff, if you don't build it early in the application's life, you will drown in maintenance by click sort of activities. You don't want to be stuck on the Amazon web console applying updates to your code click by click. That will slow you down like quicksand. So that's a lot of what I've done over the past 6-8 weeks really. In addition to adding features, I've added the deployment engine. And I've added it in a way that allows me to continue adding the features I need. So as I said, I haven't run the build all, deploy all script in a long time. It might blow up on us, but it's dependent on all the other scripts I'm running by hand one by one anyway, so it's unlikely, unless I rename something and forgot about it. And I have done a bit of that. So far, so good. You have to deploy Lambda functions as, well, you can either type them in by hand, which would be insane for any application of note, or you have to deploy them as zip files using their command line tools. So I downloaded 7-zip to take care of my zipping needs, and it seems to be compatible with AWS Lambda. To look, see if I have any live viewers. I have, oh, a message. I don't have a message. How can I have a message if I have no viewers? Doesn't seem, uh-oh, where do my messages go? Thought it said I had 1 message. Messages per minute, yeah. What does that mean? At 1:15 I got a message. Well, I didn't see a message. If you sent a message, I'm not sure why I didn't see it. But I only see 1 viewer, so I think that's a bogey. Well, look at that. It didn't even blow up. Amazing. Now, all my functions will undergo a cold start because I've updated the Lambda code. So when I run my system test this time, it should run a lot slower the first time through anyway. The other thing I want to do is delete all my logs that have accumulated in CloudWatch. So the CloudWatch home screen, you hit logs over here. And I did talk about logs earlier in this podcast, but here you can see here's my arbitrate function. You'll see it says log group. So there's a group of logs for my arbitrate function. And look at all these different ones. This latest is the version of the code that it's running. And then this is just a magical opaque identifier of some kind. See a 49 there, it was running a specific version of a function. But anyway, since these are different threads of execution, and a given customer request gets passed from a function to function to function to function inside my architecture, there's really no way to correlate the path of a particular user request through all these log files. Now, AWS does provide a way to download the log files, and I think you can stick them in Elasticsearch, or maybe there's another couple of engines that love to ingest this sort of stuff. And you would be able to issue queries to piece, provided you recorded what was needed, you'd be able to piece together the thread of activity for a given user request. But in my case, it seems simpler just to log it myself, rather than deal with all these logs. So the other utility you should, oops, that's not right. The other utility you should really build for yourself is a clean up all my logs sort of function. So I did build one of those. It's called log delete. And that'll just whack all those log groups. So now I have clean code. I'm going to delete the rows out of the database as well. But I've lost my DynamoDB window. There it is. So I'll delete everything from request history, it's empty, and logmaster. So now I have a clean slate. Nothing in the database, nothing in the log files, nothing in the, I guess that's it. Okay, run the system test. Now, given that I've deployed all new code all across all services, this could also blow up. But it doesn't look like it's going to. You see how much slower it's running now as it cold starts all the components. So for anything that demands fast response time, but you have infrequent calls, it means you're going to need some thread kicking around on some box that occasionally pokes that service to keep it warm. Okay, well, ran like a champ. I guess all my build scripts and deployment scripts are working fine. Next question is, did I get the data I expected? So, yes, I expect 2 locks and two deletes. So this would have been a delete, and it still says lock grant. That's amazing. Where the heck is that coming from? I bet it's leftover data somewhere. Well, no, because I deleted all the data, didn't I? Boy, that's a weird one. So it didn't fix it. What's this one say? That's the full boat. That's the lock request. There's another lock request. And lock grant. That's the lock delete. Isn't that something? So I didn't get my new message in there either. I wonder if it's glued to the wrong version. Let me check that. So in CloudWatch, that's delete log. There's an error loading log streams, really? Well, I've never seen that before. Huh. How about some of my other log streams? That's fine. Arbitrate, fine. Look at that, it removed delete log. Huh. Refresh, please. Wow, that's creepy. Where did my delete log file go? It was there a moment ago, wasn't functioning correctly, now it's just gone. That is spooky. I do not want that behavior in production. Jeepers. These things are a pain in the butt. I enabled API Gateway CloudWatch logs on one of my APIs, and it created that log stream. But look at all the log streams inside this log group. So I don't know what's that is costing me in terms of I/O or data storage, but I don't want these logs. And I can't turn them off. I even posted a question on the AWS forums. Maybe I got an answer today. I'll have to look. They let you turn them on, but I couldn't find a way to turn them off shy of blowing away the REST API entirely. And actually, I did that, and they came back when I recreated it, as though it's attached to the API name rather than its ID. Anyway, I'm just going to get rid of these stupid things. I really, and what's in them? They're all empty. So I'm not using them correctly, obviously, so I don't even want them, but it's just unneeded clutter. As soon as I find out how to turn that off, I will. If anyone from Amazon is watching this, please go find my question in the forums and tell me how to turn it off. And I'll be glad to include the instructions right here. Thank you so much. Okay. So what the hell happened to my delete lock? That is spooky. I'm just going to put those away for the moment. And I'm going to clean up my database again and rerun the system test and see if AWS will decide to keep my logs this time. And you wonder why I'm building my own logging system. This is one good reason. Although, until now, it was a completely unknown reason. I had no idea that those logs could be undependable. Okay, I deleted my request history. Let's just rerun the tests. Seems to be moving along a little quicker. Maybe not that much. Okay, did we get what we're supposed to get? Block grant, that's the delete. And that is the lock request. So it's still broken. Did we get a log file? CloudWatch. Refresh. Oh, that's bad. That is bad. Well, I think I have to dig into API Gateway next and see what's going on here. Usually when that happens, there's an integration problem. So for that, I need to look at this. Oh, cripes. No, it can't be. Oh. That's not integrated with API Gateway. That service is integrated with SNS. So it could be an SNS problem where it's configured to call the wrong version. Looks fine to me. Why aren't you working? I've had other problems with SNS subscriptions too. Got another question on the forums about that. Let's see what happens. But essentially, when I create these subscriptions via my automated build and deployment mechanism, the subscriptions don't work. The Lambda functions don't fire. I don't get CloudWatch logs. But if I come in here and I delete the subscription manually right here in the web interface and add back in exactly the same data, the subscription works. So there's some bit of magic in there that I don't quite understand just yet. But if I, well, let's just see if I did get an answer on the forums. Fire up another tab here. Go to my stuff. And it looks like, oh, I don't know. So let's start with this one. Lambda function won't fire. No, nobody answered. How about, oh, I'm also having trouble with my mapping templates. I cannot deploy those automatically to API Gateway. A mapping template tells tells API Gateway how to map the request parameters coming in on the URL or the post body into your Lambda function. And I can deploy one of those manually through the web interface again, but I can't get it working through their API, their SDK. And how do I disable CloudWatch? Also not answered. Well, it is Monday morning and it's only, what, almost 2 in the afternoon. So I would imagine they're just waking up and getting to it out there in California. And I wouldn't expect them to take on my amateur level questions in the forums over the weekend, so that's just fine. Okay, so no luck on the forums. I'm not gonna drag you through the debugging of why I'm not getting the right message on the table. Why I'm getting lock grant instead of delete lock. That just might be a really boring sort of thing for you guys to watch. But when I find it, I will, at the top of the next video, I'll certainly mention what the issue is and how I found it. But I did promise to describe how I come up with these unique identifiers, which is a bit of minutiae I'm sure no one much cares about, but it's kind of fun. I invented this in 1995 when I was working at Alcan Aluminum. And I had the same sort of problem there where I had a ton of C code, probably almost the same, well, twice the size of this application, I guess. And public API, that'll work. And I had the same sort of problem where I had 5 processes running on a machine, and each was a body of C code, and all these processes sent their messages to a central listener who would record them. So when I get messages in the log, there's a central log. I needed to know where they came from, and inevitably I'd search for some particular string that I found in the log, and I'd find that string in 4 or 5 different pieces of the code, so I didn't know exactly where in the code it had happened. So what I did was I thought, well, from now on, whenever I write a message to a log, I want to make sure, oops, holy smokes, I never updated this one. I want to make sure it has a unique identifier on it. And then when I search for that identifier, I will find it only in one place in the code, and I will know exactly in the code where whatever it is happened. Now where this falls down a bit is in copy pasting code and forgetting to update these identifiers. And I did find one of those a couple of times where I went searching in the code for the particular identifier and it showed up twice. So I had to go in and tweak the code to make one of them unique. And after that it was fine. But in general, this saves you a ton of time debugging if you have unique identifiers in your error messages, or some way to guarantee that anything you see in a log file you can uniquely track down in the code. So what I did was I invented this little code. It's actually an alphanumeric code. You see all numbers here, but it depends what time of year it is. So the way this works is essentially it's year. I'm going to put a space between these just to make it clear. And year will be how does this work? 6, 7, 8. Right, so it's just the last digit of the year. So it's a 0, a 1, a 2, a 3, or whatever, up to 9. So that's a 0 to 9. Then comes the month. Now the months go to 12, so I co-opted some hexadecimal digits for that. And month can be, well, there's no month 0, so month 1 to C. And then the date, which today is the 22nd, so that's DD, 22, oh, DD, so it would be 1 to 31, and then hour, and what I'm attempting to do here is keep this unique identifier as short as possible. I don't want some big, long, unwieldy thing. Hour, of course, is 00 through 23, and then mm, which would be 00 through 59. Now, so using this magical template, if I wanted to, if I was writing an error message right now, I would say, well, it's 2016, it's August, it's the 22nd, it's 13:48 in the afternoon. There's my unique identifier. Now, sometimes you write 2 or 3 or 4 error messages all within the same minute, and that's fine. So 48, 49, 50, 51. As long as you don't write your next one until 13:52, you're fine. So I've never had, you can count backwards or forwards, it doesn't much matter, because you never need a unique identifier more than once or twice an hour anyway, so this works fine. Now, if I was on a team of 10 guys, I'd give them each a letter of the alphabet, and they could put their own letter of the alphabet at the front of the thing. And that way, you make sure that 2 people writing code at the same time never generate the same unique identifier. Anyway, that's enough minutia / trivia for today. So I didn't get any live visitors, I don't think, but thanks to anyone who catches this on video. And at the next one, which will probably be, I'm guessing around midnight tonight. I like to work through the night when it's quiet. So around then, hopefully I will be able to explain the answer of why that message is still showing up in my database table wrong. So thanks, and bye for now. My OBX.